Confirm everyone. Yeah, so this was the last thing that we did. And we did this force also we did now. Great. Did we do this also? Let's do one more question. Let's start off with the question. So we have a okay, Gauri, that will be fine. Okay, Renu. Okay, let's start off with the question. Let's say we have two pendulums here. Length L, mass M, charge Q, mass M, charge Q. This angle is 60 degree and 60 degree. This is in vacuum. They are in equilibrium, okay? Gravity is there. Then what you did, you place this entire setup inside a medium. Entire setup is placed inside a liquid. And then what happened? The angles became 30 and 30. Mass same, charge is same. And this entire space, right, is filled with medium. Density of the liquid is rho. Dielectric constant or the relative permittivity is epsilon r. Are you getting the scenario here? So initially, when in vacuum, the angle between the bobs, because they repel each other, is 60 degrees, 60, 60, 120. When you take this entire setup and place it in a liquid, something happened and the angle became 30. They came closer. Find the density of the bobs. So what is the density of this masses M here? Think what is happening here. It's a good one. So we have two pendulums suspended at the same point. They're in equilibrium. Angle is 60, 60. When you kept them in a liquid, it suddenly became 30, 30. Density of the liquid is rho L. Dielectric constant is epsilon r. I hope you revised everyone. Dielectric constant is what? Whenever you keep two charges inside a medium, the force on each charge becomes F by epsilon r. Force on each charge. Get this. It's a good one. This would be advanced easy to moderate question. Abhiksha, can't see you. Your cam is blank. Ammo, okay. Okay. How to do this? First of all, why did the angles change? Anyone didn't get the question? Please ask me. Question is clear. Go ahead. You got 2 minutes. Any ideas? Anyone? Initially, how many forces are there on each bob? Initially, how many forces are there on each? Three, na? What are those? Tension, mg, repulsion. Second case, how many forces are there? Four. What is the fourth one?
Due to the medium.
What is that? Uska naam kya hai? What is it?
Normal force.
है liquid ray.
Attractive force due to medium.
Nah, that is anyway, that is taken care by Coulomb's force, right?
So buoyant.
Buoyant force, gods. Liquid का buoyant force होगा. Fluid mechanics, people. So if you draw the initial FBD, right? This is the FBD of initial. This is 60. This is 60. Oh, if my voice is lagging, let me know. Huh? Today I don't know what happened. Network is pretty bad for me. So this is the repulsion force. Let's call it F1, and this is mg. This distance is 2L sine 60. This angle is 60 degrees. So we get tan 60 is equal to F1 by mg. F1 is how much? K q square by distance square. 2L sine 60 is L root 3 whole square. In the second case, the distance also changed. Be careful, because this angle became 30 and 30. Now, if you look at the forces, this will be F2, this will be buoyant force, this will be mg, this angle will be 30. This distance is 12 sine 30, and sine 30 is half. So we get tan 30 is equal to F2 opposite side by mg minus buoyant force. And what is F2? F2 is k q square by epsilon r. Distance is L square. Is that making sense? Distance also changed, and because you're in a medium, the force becomes 1 by epsilon r times. The repulsion force between them will actually change because of two things. The distance between them has changed, and this also has changed. And then I think you're done. Just divide them, equation 1 and equation 2. Tan 60 by tan 30. This is k q square by 3L square mg divided by k q square by epsilon r L square mg minus buoyant force. K square will cancel. L square will cancel. Tan 60 is root 3. Tan 30 is 1 by root 3. That will become 3. This will become epsilon r by 3. What is mg? Density of the body, volume g. What is buoyant force? Density of the liquid, volume g. By m is again rho b vg. Vg will cancel. You end up with rho b 1 minus rho liquid by rho b is equal to 9 by epsilon r. So we get rho b is equal to epsilon r minus 9. You can just simplify this shit. What happened? This will be rho L by rho B will be epsilon r minus 9 by epsilon r. So density of the liquid will be rho liquid. Dielectric constant minus 9. Check. Epsilon r ka value I could have given some 10 or 11, 12, anything. So primarily two things happened. The distance changed and the force became 1 by k times, and the buoyancy force is Fb in the vertical direction. Check. NLM, fluid mechanics, electrostatics. Anyone confused any step, please ask. Vrinda, Anamai, clear? Nishita, got this? Perfect.
So the second step in the blue that you have done, I'm getting a bit confused there.
Kaun sa step ye?
So नीचे वाला.
This one. Mg is what, right? Rho body volume G. Buoyancy force is rho liquid volume G. सब छूट गया था बस भाई.
Okay, sir.
V is volume. Clear? Next one. Now, if you see, right, we have dealt with forces and all, but theoretically, right, people always have this problem. Whenever you are trying to see a phenomena, scientists are always allowed to explain it with some theory. So the biggest problem these people faced is, if you keep two charges, Q1 and Q2, how does Q1 know that Q2 is there? You're getting? So their question was, how do two charges talk to each other? How do one charge know that there is one more charge there and I should repel it? So people explained it, they came up with a theory called field theory. So this field theory is common for gravitation, electrostatics, and magnetism. The idea was same. It is completely hypothetical. So force is actually the real one. The field is actually hypothetical one to explain it. So the theory, right? The theory always thinks as a field, because of field, there is a force. Whereas in reality, you created field to explain force. Are you getting the difference? So it is like kind of saying God has created humans, but the concept of God was created by humans. Getting it? So it is kind of like that. So what is this field theory exactly? So a body modifies its surroundings by emitting field lines and when another body enters this region, they interact with each other. Now, this thing, right? Think of like this. I think the guy who made up this thing, right, must be inspired by a spider. If you ever seen a spider ka web, how does the spider know that there's an insect? So the spider is just sitting there and waiting. And when an insect comes and hits the web, right, there are vibrations passing through the web. That is how the spider will go there and catch that whatever insect is there and come back. So the idea is the same thing. So we have a charge Q somehow. So this is emitting something called field lines. Like I said, completely hypothetical. And whenever someone enters this region, that is how the charge Q knows, okay, there is someone there. So positive charges emit field lines and the negative charges actually, the field lines converge at the negative charges. Then properties of field lines. So what are these properties of this field lines exactly? A little bit of theory. So first one, the field lines diverge from the positive charge. Why they should diverge? Completely hypothetical. We have just assumed it to explain stuff. Diverge field lines. The field lines diverge from positive charge and converge at negative charge. That is the thing which I have drawn just now. The number of field lines is proportional to the charge. So this was a question I asked, I think in bits or seed, I don't remember where. A question was something like this. We have a charge Q1 here, we have a charge Q2 here. The field lines were like this. The question was find Q1 by Q2. What is the answer? Simple main scale question. So just give like this and said find Q1 by Q2.
Greater than 1.
Give me some number. Greater than 1 क्या होता है? Good thing you didn't say it's a number. 11 by 8. See, how do you do this? Count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8. So Q1 say 11 lines are going out. So it is plus 11. 8 say minus negative 8. So be careful, sign matters. It's 11 by minus 8. Because the charge, the lines are converging at Q2 should be negative charge and Q1 should be positive charge. And the ratio of the charge is 11 by 8. So the number of lines is proportional to charge. That is the meaning of the statement here. So more lines you get from a charge, the more the charge is. Yeah. Easy. Then, can I turn the page? The number of lines per unit area is proportional to the magnitude of field. If there are more field lines per unit area, the magnitude is more. So here, if you see the intensity is more, there is a more cluster there. So the field ka magnitude at A is greater than field ka magnitude at B. Tangent to the field line gives the direction of the field. That means if you have a field line like this, the field at any point will be a tangent. So because of this, two field lines will never intersect. Why? At the point of intersection, you have two tangents, does not make sense. So field lines will never intersect. At the point of intersection, there are two tangents. Means you have two directions. That doesn't make sense. You can't have two directions at the same position. Check. The fifth point, field lines propagate with the speed of light. This is interesting. You know the meaning of this? Meaning the gravitation experienced by the Earth due to the sun was actually released 500 seconds before. Think of it like this. Whatever light that you're receiving on the Earth due to the sun is actually 500 seconds old. If sun suddenly vanishes for some reason, what do you think will happen? Let's say sun is there and the Earth is going in a circle. And let's say sun suddenly vanishes. It takes 500 seconds for the light and the gravitational field to reach the Earth. That means the field which was released by the sun, right, that is still being received by the Earth. And then it will fly off tangentially. So means for 500 seconds, the Earth will feel as if nothing happened. The light is still coming from the sun. The gravity is still coming from the sun. Everything looks pretty normal. After 500 seconds, suddenly it becomes dark and the Earth will fly off in tangential direction. So it takes actually 500 seconds for the field or the light to reach from sun to Earth. That means every time you see in the night sky, what you're looking at is past. The nearest star we have is Alpha Centauri, 4.2 light years, meaning it takes 4.2 years for the light to come from that star to the Earth. So when you see in the sky and see a star, you're actually seeing the position of the star some 1,000 years back. If you see an Alpha Centauri star, that star ka position was actually 4.2 years ka position that was. The star is not there anymore. You're getting it? So every time you look in the sky, what you're seeing is past. And interestingly, some people, right, look at that stars and planets and they tell you a future. The stars themselves don't have their own fixed positions. Put on these things. So keep that in mind. Next thing. What is the difference between a field line and a streamline? We have studied streamline in fluid mechanics, remember? So let's say we have streamlines. And we have field lines. And if you put a particle here, and if you put a particle here, what will happen?
Both follow the same path.
No. What is streamline ka definition? Streamline is the path of the particles, right? Streamline is the path of the particles. This will follow the streamline because the definition is it's the path of the particle. What is a field line? Field line is the direction of force, right? Field line is the direction of force. It is not the path. That means the moment you give the particle here, force is which way? Force is this way, no? So particle will go which way? The particle will actually go in a straight line like this. Once it reaches here, now what is the force ka direction? This will be the force ka direction, no? You're getting it? So velocity is in some other direction, force is in some other direction. So you'll actually bend like this and you'll go like this. Are you getting this? So it won't follow this path, so this thing will follow the streamline, moves along streamline. So whereas this thing will get flied away, tangentially it will fly off. It is tangentially pushed away. So be careful, field lines and streamlines, both are different. You won't follow the path, you will just fly away tangentially. If you go to another streamline, a field line, then the force will become tangential, you'll go in some other way. I hope this was clear. Streamlines are real, streamlines are real. Forgot, kya? I showed you the video of the color and all. Is this clear, everyone? So this is one. Now, if we go into more technical definition, electric field intensity, that is a full name, we will just call it field. We are lazy people, so yeah. The symbol is E bar. The definition is, it is the net electric force per unit charge at a point. Meaning, it is simply electric field definition, P bar is equal to force by charge. This is the main thing. You need to remember this. F is equal to Q E bar. So if the charge is positive, it will go in the direction of the field. Negative charges will go opposite to the field. Positive charges. Force on positive charges is along the field. Negative charges is opposite. Vector it is. This is the first thing you need to remember. Next thing, from this definition, if you have a charge capital Q here, if you have a point P here, and let's say if you bring a small charge Q here, the force will be Q by R square. So the field at point P due to this charge will be K. Definition is F by Q, Q by R square. So this is the field due to capital Q at point P. So field due to a point charge is Q by R square. Now, one thing I'll tell you, don't get confused between force and field. It is nothing new. So whenever you get a confusion, sometimes people do get confused. What is force? What is field exactly? Think of like this. Whenever you write something theoretically, right, people like to keep it in general. Meaning, I'll give an example. Imagine I am selling apples, okay? I buy an apple for 90 rupees and I sell an apple for 100 rupees. Now, if I sell 5 apples, what is the profit? 50. If I sell 10 apples, 100, 23 apples, you will say, sir, wait. Sir, per apple, it is 10 rupees. How many you sell, multiply, na? So same way, at a point per unit charge, the force is Q by R square. Whatever charge you bring, simply multiply. Are you getting it? So basically, by defining per unit charge, you can ignore one more variable. You need not know what is the second charge. Just like how you define density. Why don't you say mass of the water? Because it depends on the volume. But if I define density of the water, it is 1000 kg per meter cube. For 1 meter cube, weight is 1000 kg. How much over water you bring, multiply. So field and force are exactly one and the same. The only difference is field is nothing but force on 1 coulomb charge. Q1, Q2 by R square, Q2 became 1. Are you getting this? That's it. So theoretically, whenever you're confused what is force and field, simply think like this. Field is simply a force acting on one charge, 1 unit ka charge. So mathematically speaking, there is no difference between both of them. Clear? There. So if you have multiple charges, then what will happen? Let's say point P is here, and if you have multiple charges Q1, Q2, so until Qn. Remember, field is a vector quantity. So this is E1 bar, E2 bar, E3, En bar. So the field at P will be E1 bar plus E2 bar plus so on till En bar. So if you try to draw the field lines for multiple charges plus Q and plus Q, the field lines will look like this. This point here in the center where there are no field lines is called null point. So null point means the field is 0. If you have a plus Q and a minus Q charge, then some of the field lines will this is how the field lines will look. Later on, we will draw more even different varied varieties of field lines. Have a look at this. Clear? Let's see a question. Remember, field there are only two things: KQ by R square and force is equal to Q into E. Let's start off with an easy equation. A particle is projected with u, theta, mass m, charge q. We have gravity also, we have field also. Find range, time of flight, and h max. Let's get this projectile. Pratham, cam on. Apeksha, your cam is still blank. First, we'll finish off field and potential for point charges. And then we'll do for continuous bodies like rods, arcs, and all that stuff, integration stuff. This is what I said, we couldn't do this kind of questions, repulsion pairs, these kind of things in gravitation. Electrostatics is like a much higher version compared to gravitation in this case. I hope SHM test everyone gave. Today night 11 o'clock is the deadline, so you guys should have given it by now already. I did extend it one day.
So do you sign theta into that?
So spherical conductor will be different than sphere insulator. Yes, Ritam, they'll be different. How to do this thing? See now, you just have to see, if you look at the forces on the body, what are the forces? mg, EQ. Agreed? So the net force will be mg plus EQ. So the particle will think this is acting like m into g effective. Na? Remember the g effective concept? So g effective is g plus EQ by m. So the particle will think the gravity has increased. It doesn't care whether it is electric force or this thing. हो गया ना? What is range का formula? U square sin 2 theta by g effective. What is time of flight? 2u sin theta by g effective. Wherever there is g, just dump this g effective. H max u square sin square theta by 2g effective. Easy? Where else can you use this g effective concept? Same question if I had asked you like this. Any doubts on this page? Same thing, g effective ka question I can ask you like this also. Let's say we have a pendulum here, mass m, charge q, we have a field downward. We have a pendulum here, mass m, charge q, field E upward. Gravity is there. We have a pendulum, field E, length L, and gravity. Find the time period for small oscillations. I can bring SHM and electric field or projectile. I think only chapter that is left over is optics. We are bringing literally every chapter. Heat and thermal also we can bring, but let's see later on. How to do this thing? Try. I'll give you a minute. Yeah. So basically, you have to find G effective. The first case में G effective will be G plus EQ by M. So mg plus EQ is equal to M into G effective. Second case में G effective will be G minus EQ by M. What about the third case?
The resultant and then length along that G effective.
EQ mg na, so resultant will be this thing F net. So F net will be root over mg square plus EQ square is equal to M into G effective. So G effective will be root over G square plus EQ by M whole square. What is the time period formula? 2 pi root over L by G effective. Clear with this G effective stuff. So you could bring G effective like this also. Till now we use G effective when the lift was accelerating with A and all. Here there's a force EQ, that's the only difference. Because the Bob doesn't care whether the force is coming because of gravity or electric force, it is force. Have a look at this. So we can use this electric field in pendulums and projectiles also. This idea is important. Especially later on when we do questions in capacitor plates, you do get this kind of questions. They will say there's a plate here connected to a battery and there's a pendulum in the middle, find the time period for it. Any doubts on this or the previous page, please ask me. This or this projectile, any doubts? Anyone not clear with any step, please ask. Clear? Previous page. Geet, Jaini, Aname, clear? Dania, Amu, Trisha, got this? Next one. We have a hexagon, plus Q, minus 2Q, plus 3Q, minus 4Q, plus 5Q, minus 6Q. O is the center. It is a regular hexagon side A. Find the field at the center. Remember the formula KQ by A square. That's it. That is the formula. KQ by R square. But there are 6 charges. Last time we did for the clock, no? 12 charges. This time I gave 6, but I kept the alternate charges, plus minus signs. Find the field at the center. I want in terms of I cap, J cap. You can treat this as x-axis and this is y-axis. Find the electric field at the center. Try 2 minutes. Everyone should try just vectors. It's a good one. I guess. let's call E is equal to K cube by A square. Remember, K Q1, Q2 by A square, 1 Q won't be there. So what I'll do now for simplicity, let's say this Q, right, is pushing. So this field is E. This is minus, na? So it'll attract towards it. So this will be 4E. This is 5E. This is 2E. This is 6E. This is 3E. Isn't that the vectors? So if you just take the resultants, you'll observe this is 9E. This is 7E. And this is 5E, all making an angle 120. I can write this thing as 5E, 5E, and 5E plus 1 4E will be left over because 9 minus 5 is 4. And this is 5, 7, 2E. And this angle is 30 degree because total 120. This will be 0, no? If three vectors of same magnitude makes 120 degrees with each other, they'll cancel out, no? Equilateral triangle. So you're only left with this thing. So what is the resultant of this thing? Components minus 4E plus 2E sine 30 I cap plus 2E cos 30 J cap. Therefore, the field at the center will be minus 3E I cap plus E root 3 J cap. Check. You could have, if you didn't like this method of cancelling it out, you could have taken 7E ka components, 5E ka components, and you could have done it. You would have got the same thing: 7E cos 60, 5E cos 60, 7E sin 60, 5E sin 60, I cap, J cap, finish it off. Is this making sense, everyone? Everyone agrees this will be 0? Please check the steps. Ask me if you're confused. So I took E as K cube by A square. I just represented everything in terms of E, and then it is just vectors there. Anyone confused with this? Please ask. Clear. Next one. Any confusion? Anything not clear? Dipanshu, clear? Sit straight. Don't put your hand on the head. Sit straight. Then next one. Shaurya, clear, na? Gauri?
Yes, sir.
Nabdi, clear with this? Divyanshu, Ishita? Perfect. Next one. Let's do something a little more dangerous. So we got a no slipping. This is the solid sphere of mass m and radius r. The upper hemisphere is uniformly distributed with a positive charge. So upper hemisphere is having uniform charge distribution plus Q. It's an insulator, so Q. Similarly, the lower hemisphere is having negative charge minus Q. At T0, you suddenly switch on the field. Okay, so find. So when you switch it on, suddenly what will happen? The positive charge ka force will be this way, right? Negative charge ka force will be backward, na? So the body will try to rotate, isn't it? So the body will actually rotate. Find the acceleration of center of mass angular acceleration, the friction on the ground at t0. It's a nice concept. So the entire upper hemisphere is having positive charge, the entire lower hemisphere is having negative charge. You applied a uniform field, constant field at t0, you switched on suddenly. The ball will start rolling. Initially at t0, I want you to find the acceleration and friction. What is the catch? Think about it. This will be a proper advanced paragraph question. I can ask you even a lot of questions. Find omega as function of theta, describe the motion of the body. I can ask you a lot of stuff like this. That you need to figure out, Danya, why it will roll. So, Jana, on the upper part of the body, positive का force किस तरफ होगा? It will be right side. Negative का force will be back side, na? Isn't it a couple? Torque. It's a couple. Force will cancel, but there's a couple. And there's a ground where there's a friction also now. It is rough. If the ground was smooth, the body would have just rolled, but because the ground is rough, the friction won't let it slip. So this will start translating also. Think. It's a good one. So more questions I'll just add up here as a homework you can try. Find angular velocity after as function of angle rotated. And describe the motion. Think. Try 2 minutes, 3 minutes more. It's a good one. हाँ Shaurya.
Sir, we can assume like जो force लग रहा है वो 3r/8 center of mass पे लग रहा है, फिर torque और aerodynamic quotient दोनों कर सकते हैं.
Maybe. Think, try. Not a bad idea. Just give it a try. I'll get some water and come. Let's see. Actually, Shaurya has a right idea. Now, why is that centromas thing coming up? That is what we need to see. Let's see. Let me ask you something. Suppose if you had only this hemisphere, gravity is there. tell me one thing. When you say mg is acting, where is this actually weight acting?
At the center of mass.
Right. But in reality, if you look at this, at every point you have a small weight, isn't it? dmg, 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 dmg. For convenience, you took the entire mass at center of mass and you said this is mg, isn't it? Whereas in reality, the weight is acting at every point on the body. Does that make sense? Now, when you look at this scenario here, when you take this half hemisphere, how is the force acting on this at every point? Field into dq, field into dq, field into small dq charge. Now, if you ask mathematics, okay, if you see mathematically, Max doesn't care whether you call this dm or dq, whether you call this g or e, isn't it? Max will simply say, mathematically they look identical. It is you and I who is calling it, this is mass, this is charge. Max says, I don't care, isn't it? That means we can assume all this charge is acting at the center of mass, and we can assume the force is eq. So this is an important statement here. So in a uniform field, we can assume the entire charge is placed at the center of mass. Keep this thing in concept, but only for uniform field. If the field is changing, you can't do this. So center of mass came for the which time? Fourth time. First time it came in center of mass. Second time it came in rotational mechanics. Third time it came in fluid mechanics. Pressure at the center of mass into projected area. So this whole question becomes as if, now where is the center of mass per hemisphere? 3r/8. Now if you forgot that, the whole question is gone for a toss. So this is plus q. This is minus q. And this distance is 3r/8. And this distance is 3r/8. So the forces will be on this guy, EQ. I'll show it in the next page, but have a look at this page first. Quite a useful concept. For uniform fields, you can just replace with center mass and finish it off. Any doubts on this idea, please ask me. So this is one very important idea in physics. If something you are learned it in one chapter, and you see something similar in another chapter, only the symbols are different. Max doesn't care. And recently, I was teaching your seniors damped oscillations, which you did in SHM. The equations look exactly same in alternating current. So we are relating springs and resistors, and we are solving problems. And the answer is exactly Max. Clear with this? Then now draw an FBD. What are the forces acting on the body? At this point, you have EQ. At this point, you have EQ. This distance is 3r/4. Basically, it's a couple. On the ground, you have friction. We have acceleration of center of mass and alpha. So whenever there's no slipping, what's the best point to take torque?
Bottommost point.
Bottommost point. So torque about A will be friction ka torque is 0. It's a couple. What is couple ka torque? EQ into 3r/4. Torque about a couple is same about any axis. EQ into distance between the two forces is equal to moment of inertia about A into alpha. So 3 EQ r/4. I about A is 2/5 mr square plus mr square 7/5 mr square alpha. The alpha will be 15 EQ by 28 mr. A is equal to r alpha. Friction is the best. F is equal to MACOM. एक step में आ जाएगा friction. Because EQ will cancel out. The only force is there friction on the ground. You get everything. If you see actual solving is easy. The main headache is figuring out, then you can apply the force at center of mass. Check. Now tomorrow in the exam, they can ask you a question like this. They'll give you half disc or half ring, half positive, half negative. What is half disc center of mass?
2r/pi.
Yeah. Half disc gods. Gods. Reena, half disc center of mass.
MR square.
Half disc center of mass. मोटा
Have to,
connection नहीं.
sorry.
Wake up, Gauri. Gods me, सब ना telling me ना we should 4R by 3 pi drunkards. 2R by किसके लिए? Half ring था वो.
Yes.
Don't forget. You gotta solve from there. All clear with the steps. Check it out. Clear? Next one. This is another standard question. Length L, mass M, charge Q. At someone suddenly switched on the field at T0. Find maximum angle deflected. Initially, field is not there. When you suddenly switch it on, what will happen? The force will drag the ball. So what is the maximum angle deflected by the ball? Meaning after some time, the ball will actually become like this. So this I'm asking.
Sir, df by dt.
Yeah. Try 2-3 minutes. How do you do this? This is a standard question. And the best part, you know what? We have encountered this before. You know where? I think we did that. Not the exact one. It's something similar. Where is that? Yeah. Do you guys remember this question? F1 is always horizontal. Isn't the same as electric field now? EQ, EQ, EQ always. Idea is the same. You have to actually use work power energy. Try. I'll give you a minute or two. Differentiate with respect to equal to shower. Yeah, God, you are. Differentiate with theta. किसको theta से differentiate करोगे शौर्य? The statement you said, I said find maximum theta, and you're saying you'll differentiate theta with respect to what theta?
Sir, the force along the
करो करके देखो. Create some new techniques in physics. You'll get either a Nobel Prize or aliens will come and kidnap you. Happens. You can create new physics. Come on, Dipanshu, solve. What happened, Raina? Today you're tired?
A little.
How was your trip? You went to Ukraine, right?
No, sir. I went
No.
Bali.
Okay. You said, sir, I'm having 1 week vacation. I'll go and fight a small war and come. Chalo, good. My half the vacation was busy with taking PTMs. And someone was saying, sir, this time PTM you didn't scold much. Said like, acha, good. People have a good opinion about me. Then I told him I'm from my hometown, my network is bad. That is why. He needs an explanation. Then he's satisfied. He's not happy that I didn't scold enough. How do you do this thing? I'll show you something. So this question, right? Let's say, let the force be EQ, let the force be mg, and let this angle be phi. This is phi, so I'll write tan phi is equal to EQ by mg. Is this okay? This is wrong. Why? This is a mistake. This is wrong.
Centrifugal forces also.
Centrifugal, क्या बात कर रहे हो? तो God है तो centrifugal forces. See, at this point, what is this position? This is the point where the net force is 0, right? This is a mean position, na? Here, net force is 0. That means when this guy is going from here to here, do you think it will come to rest here? Won't it have maximum speed? Because initially, when you're applying a force and pulling it, isn't the speed increasing continuously? Initially, force EQ is there. So EQ ka component is greater than mg, right? There is no one to cancel EQ there. So the body ka speed will increase. At this point, EQ ka component and mg ka component will cancel out. So it has come to the mean position. But the speed is maximum. So it won't stop now. It will continue to go further. And finally, somewhere it will stop here. Can you see the logic here? Doesn't this look like what? This is the extreme position. This is another extreme position. So if this is angle phi, what will be this angle? Phi, na?
Phi.
Double the angle, isn't it? So it won't stop at the mean position. So how to do this normally? Let this whole angle be theta. This is step 1. This is state 2. So I'll just draw that figure again. This is L. So this distance will be L sine theta. This distance will be L into 1 minus cos theta. The force F is always acting horizontally, EQ. So work done by external field or external force is change in potential energy plus change in kinetic energy. So the mistake what most people do, they think equilibrium position is the angle, maximum angle. That is wrong. It won't stop there. It will continue to go further. The work done by electric field is EQ. Since the force is always horizontal, the displacement is also horizontal. Horizontal force into horizontal displacement. Initially velocity is 0, finally velocity is 0. So only there's a change in potential energy. Sin theta can be written as 2 sin theta by 2 cos theta by 2. 1 minus sin theta can be written as 2 sin square theta by 2. This is 1 minus cos theta. This turns out to be tan theta by 2 is equal to EQ by mg. So theta will be 2 times tan inverse EQ by mg. What is EQ by mg? Phi. So this is 2 times phi. Make sense? Keep this in mind. Huh? Don't do this thing. Most people do this, and this option will be there in the exam. Proper mains and bits level question. This is standard one. If the question is field E is applied, find the angle in equilibrium. Wo alag hai. This question, see, this SHMA when we did this was an angle in equilibrium. This is already at rest. And then you disturbed it for oscillation. This question is not that. Initially, it is vertical, you suddenly switched on. So it started moving up. So this will never stop. Huh? This will always oscillate like this. Do have a look at this. It's a good one. Any doubts on this? Please ask. Clear?
Sir, but if that it is the mean, then theta will be obviously be 2 phi.
Theta will be always 2 phi. Why you could have just seen that and told the answer instead of doing this much. You could have skipped all these things. If you just realize a mean position, a extreme position, that will go to one more extreme angle will be 2 phi. That's what I'm saying. You could have used it that way. But most people do till here and they think this is the answer. So just be careful. All got this? And this is not the first time. Huh? This is not the first time. You have a spring here, you have a block here, mass m and natural length. What is the maximum elongation? It won't stop at ng is equal to kx, remember? At this point here, mg by k ये mean position था. It won't stop here. This is V max होगा. It will go further more ना. It will go 2 mg by k. Remember? Same idea it was. If you start from rest and if you apply some force or something, the bodies won't stop at the mean position. They will continue to go further. Remember these models. Clear with this? Next one. The next one is a good one, right? I'll show you one question, then I'll ask you one. So let's say we have X and Y axis here. We have two charges, plus Q and plus Q. So we need to plot the electric field on the X axis, the X component of electric field versus X coordinate. This is the X component of electric field. If electric field is along I cap, take it as positive. Okay, how to draw? Let me show you one. But just try to understand the question. So what you're asking the question now, a man is working on this x-axis. So you'll experience field. Now. I want you to plot that field versus x coordinate. Now see the question. Now. So this was plus q, this was plus q, equidistant. So whenever you do this kind of graphs, always start from extreme position, one extreme position. Actually, eliminating graphs is more easy. Now, when you are very far from the charge, what will be the field? 0. All right. So when you are at infinity, it will be 0. Now, when you are getting close to the charge, what will be the magnitude? Kq by r square. If r is becoming 0, what will happen to the field? Infinity. Two things. So when you're very close to the charge, magnitude is infinity. When you're very far from the charge, magnitude is 0. One. Second thing. Look at this charge here. When you're on the left-hand side, the field is this way. Means the field is minus I cap. On the right-hand side, field is plus I cap. So look at the graph of it starts. So at infinity, it is 0. On the left-hand side, the field is pushing in the minus I cap direction. And as you get closer, the magnitude will go to infinity. You're getting how the graph looks? Two things. The magnitude will go to infinity and the direction is minus, so it will go to minus infinity. Once you cross the charge, the field is on the right-hand side and you're very close. So charge will come from plus infinity. At the center, both will cancel out. You get a null point. And once you cross the center, if you observe, this field is stronger than this field, right? This guy becomes stronger than this guy. So this field will go to again minus infinity. This is how it looks. Check the graph. The green indicates the right side charge is dominating. Red indicates the left side charge is dominating.
Y-axis of magnitude.
Same magnitude, no? QQ. Just have a look at this first of all. Try to understand how did I draw this. If you're on the upside means it is plus I cap. Niche means minus I cap. That is the meaning of up and down. Plus and minus indicates plus I and minus I. If you're very close to the charge, the magnitude will go to infinity. So near the charge, you'll always get discontinuous functions. Null point is the point where the fields got cancelled out. Once you cross the origin, the green will dominate. So green ka field is on the left hand side. So field will go to minus infinity. Please check. And if you understood this, can you draw this graph for me? Same question. Let's say this charge is plus Q and this charge is minus Q. You try for plus Q minus Q. I showed you plus Q plus Q. You draw minus Q on the left and plus Q on the right. Try. I give 2 minutes. A minute.
Can you repeat that for why it went to minus infinity then plus?
Where?
Near plus Q.
And magnitude is infinity and the direction is left side. When you're very close to the charge, KQ by R square R is 0. R is the distance between the charge and the point. Anyone didn't get the graph, please ask for plus Q and plus Q. Understood that? You draw for minus Q and plus Q. Try, I'll give you a minute. These graphs are quite important. These graphs in gravitation, you'll only have M and M. You won't have plus and minus signs there. That's why I said electro is a much higher version of gravitation, at least for the first 60-70% of the chapter. Only additional thing in gravitation is satellites. Try. Should I show you? Anyone got thing? Let's call this minus Q and this is the plus Q. So when your left hand side, minus Q will dominate. So look at this graph. Huh? At infinity, you're 0, but the minus will attract us. Field lines are this way. That means on the left hand side, field is on the right side. And as you get closer and closer, you'll go to plus infinity. Is that clear? So you have to see two things only. What is the direction, left or right? When you are here, what is the direction? Right side. As you're getting closer, magnitude is increasing. So you're going up. Are you sure? What is the direction here? Left hand side. Means you start from here. And then, remember, you won't get a null point. There is no null point here. They will never cancel out. Because center may, if you see now, minus Q is attracting, plus Q is also pushing. The directions are in the same direction. They're not canceling out. Isn't it? See, what is the green doing? Green is also pushing this way. So in the center, they're actually adding up. So this will go to again this way. These are the graphics. Check. So next time, right, when you're having this Rangoli competition or something and you want to draw something, you don't have an inspiration, you can use this. You can put 3-4 charges and draw field lines. It'll be pretty innovative. I think 2-3 years back when my wife was drawing, I was doing something like this only. I was bored. She's drawing all birds and flowers and all. I was sitting there, I was putting charges and drawing field lines. And then she asked me, what do you want me to draw for you? She's a painter, so she draws a lot of stuff. Then I told her, I want a peacock, kind of like this. And there is a dinosaur here chasing the peacock. She didn't understand the artistic view. I said, okay, fine. Can't help it. Clear with this thing. There's a better version of this. There's even a more good one. Something which I would say will reach advanced. What if I have 4Q plus and a minus Q? How do you do this? This is interesting. Equidistant. Any doubts in the B question? Please ask. Will there be a null point here? It will be there. Kiya tha last class. Forgot. Where did we do that? We did something na force where it will be 0. We didn't do that. So we will do it right now. This is a good one. Try for a minute, then I'll show you. There will be a null point here. See, first of all, right, let me show you something here. If this was 4q, this was minus q, this is a standard question. Let's say the distance is d. Tell me one thing, if you take a point A here, if you take a point B here, if you take a point C here, where do you think the field can be 0? Which point do you think the field can be 0?
C.
B. B में देखो ना क्या होगा? 4q is there. What will 4q do? 4q is pushing, right? What is minus q doing? Attracting, na? Center में they're adding up. It can't be a null point. What about A and C?
Sir, C.
Why not A?
Sir, because
A, we still have 4Q pushing, no?
देखो अभी A में क्या होगा ना? If you look at A, this is pushing, great. Minus q is attracting. Both are opposite. C पे this is attracting and 4q is pushing. They're repelling. But here the problem is what? 4q is already very big and you're already keeping it very close. Are you getting it? At A and C, the directions are opposite, but point A may you can't get a null point because the 4q is already stronger and the distance is smaller. So this can't be a null point. Since 4q is stronger and distance is also smaller, so it will become even more strong. Here, the fields add up actually. They can't cancel. So the only possibility is where? C, na? So for this question, if I redraw the diagram here, 4q minus q, so this point, right, x, and this point is d. So 4q ka field will be k, 4q by d plus x whole square. That is the field due to the 4q. And this will be k, q by x square. That is the field due to the minus q charge. If you equate them, kq by x square is 4 kq by d plus x whole square. Kq will cancel. You end up with d plus x by x is equal to 2, x is equal to d. So the null point will happen actually on the right hand side of the question. This was a mains question, right? Mains or bits, I guess. Simple question. I'm telling you again, mains mein they're not asking really out of the world questions. Out of 25 questions, at least 17 to 18 are of this level only. The paper has become pretty lame. And that's why you need to score. Because what matters in the end is total score. No one cares about how much you're scoring in individual papers. As long as you can push our total score to 160 plus 170, you'll be in a pretty safe position. We can completely focus on advanced and bits after that. If you get even a rank of like 13, 15,000 in mains, that will put you in a pretty good NIT. And then after that first attempt, you'll have Feb, March, April, May. Literally have enough time to sit and work on it. Advanced, we just need to score at least 40-45%. So how will this graph look like now? On the left hand side, if you see, the field is this way and this way. This way will go this way. It will be somewhere till here. So till here, this guy will be strong. Then this guy will start dominating. The graph will look pretty interesting. Then this will go off. Then till here, this will be the null point. After this point, right, the plus q will dominate again. The graph actually goes up and goes down. I'll tell you why. See, if you're very far, think like this. Let's say 4q and minus q. If you're very far, let this distance be x. 4q ka field kitna hoga? 4 kq by x plus d whole square. And q का field कितना होगा? kq by x square. If you are very far, I can ignore d. So this is dominating now. When you are very far, 4q will dominate minus q. When you are very close, minus q will dominate. So the field will actually go above the null point and then will drop again. So this part of the graph, this is what makes this question tough. Most people don't realize this. At this point, right, 4q ka field is stronger. Please have a look at this graph. The red line indicates red is dominating. Green line indicates minus q is dominating. So I'm drawing the graph with two colors for that reason, so that you know who is stronger at what point.
Sir, why it changes suddenly from minus infinity to plus?
Which one?
Sir, like in 4q, it changed from minus infinity to plus infinity.
So what should you think it should be? If it's not minus 4q to minus into plus infinity, कुछ तो होना चाहिए ना शौर्य? क्या होना चाहिए? God, यहाँ पे minus and plus is simply direction. यहाँ पे direction क्या था? Left. यहाँ पे direction क्या था? Right. No, that should become minus 2 plus. Is this clear, everyone? I would strongly recommend, right? Everyone should try these three graphs again on your own. You can even try some variations also for fun. You can put something like 3q and maybe something like minus q, and you can try one or two variations. Or you can put both are minus minus. But I think if you do these three graphs again properly on your own without saying, I think that should help a lot. Rishi.
So why did 4q's field increase after the null point?
No, I'm not saying it will increase. Compared to minus q, 4q ka field is stronger here.
Yes, that I understand. But like, why did
Because
rise
when
and then fall again?
Because see, when you're close, A dominate karega. Then you got a null point. Null point means what? Both got cancelled.
Both got cancelled. Yes.
Matlab now you tell me na, means on the left hand side minus q is stronger. Why did it get cancelled? Because 4q started becoming stronger, na?
Yes.
So once you cross this null point, 4q ka field is stronger than minus q. You're asking why?
No, I understood that, but what I was thinking is it will increase and then stay at that point.
When you go infinity में field कितना होना चाहिए?
Infinity में it will tend to zero.
Zero. So मतलब if you increase, you have to decrease, na? Finally, you'll get a bump there.
Okay.
See, if you say, sir, I'm zero here, but I'm increasing, but I'm going up. मतलब क्या होगा? You have to come down, no? Got it? Yeah. Any doubts on this thing? This is a pretty good one. This graph we can't draw in gravitation because there's no positive charge. Advanced, this will be an easy to moderate question. Clear? That is about field. The next thing, potential energy. We do have a derivation, we'll not do them. It's not that important. The symbol is U. So if you have charge Q1 and if you have charge Q2, and if the distance between them is R, the potential energy U of R is given by K Q1 Q2 by R. So this we are taking the reference as infinity. That is U of infinity is equal to 0. So the actual formula is this: U of R minus U of infinity will be K Q1 Q2 by R. I think this is the main thing which you should remember. Now, example question they could change like this. Example, if someone says like this, the potential energy at infinity is 1000 joules. Then what is the potential energy between two charges? Then the potential energy between these two charges will be K Q1 Q2 by R plus 1000. Basically, you just change the reference, shifting of origin. Clear? Now, important thing, when you say negative energy, what do you mean by negative energy? So Q1, Q2 should be taken with signs. Negative energy indicates system is bounded. What do you mean by bounded system? It isn't that if you supply that much energy, you can separate them. Example, in hydrogen-like atom, we say, energy of hydrogen atom is minus 13.6 eV. Energy of electron in first orbit is how much? Minus 13.6 eV. What is the meaning of this? If we give 13.6 eV, we can, the electron goes away from the proton, the nucleus. Electron goes away to infinity. So the negative energy ka meaning is, if you use system, see, think of like this. If I say you have minus 100 rupees, what is the meaning of that? You owe me 100 rupees. Until you give me that 100 rupees, I'm not going to leave you. So bounded systems have negative energy. So you can also say stable systems have negative energy. The more negative energy, the more stable the system is. That's why we say, right, in a nucleus, the first orbit is the most stable orbit because it's the highest negative energy. So keep that in mind. Negative energy, positive energy, that's what it means in physics. Because negative force means direction, positive force is forward direction. But what is negative energy? It's a scalar quantity. Clear? So similarly, you can positive energy meaning repulsive systems. When the systems, they just want to go away to as far as possible. You can also write potential energy like this thing. This will be more useful definition. The amount of energy required. So let's say if you're trying to create a system to assemble a system by bringing individual charges from infinity. If you bring 1111 charge and put it in place, the amount of energy required to assemble that is called potential energy. By bringing individual charges from infinity. Suppose if you have multiple charges, Q1, Q2, and Q3, the potential energy of the system is K Q1 Q2 by R12. So you can choose the two particles as energy and you can just add them up. R23. Remember, there is no R square here. Check. So this is the main formula. For two particles, the energy stored is K Q1 Q2 by R. So this potential energy rate will look exactly like, like work per energy now. Remember how we used to do work per energy? Define your two states, initial state, final state. Then we used to say gravitational potential energy, mgh, spring potential energy, half kx square. Now you will say electrostatic energy, k q1 q2 by r. Got it? That's the only, then that extra thing will come. Then we can also define something called electric potential. The symbol is V. Exactly, this is same like, force and field, potential energy and potential difference. So this is potential energy per unit charge. So there is no difference between potential and potential energy. Only it is the per unit charge. So this is UA minus UV by Q. So we can simply say V is equal to U by Q, and this is K Q small q by R into small q. Completely a scalar quantity. So if you have a charge Q here, at a distance P, if you want to find the potential Vp, it is K Q by small r. Scalar quantity, you can just add it up. Have a look at this. So these are two formulas we have, potential and potential energy. So field and force are same. Field is force per unit charge. Potential energy and potential are same. Potential is potential energy per unit charge. I think you can note down these things, the formulas in the red box. Let's see some questions on this.
So we differentiate potential energy, we get force.
Force,
So,
yeah.
so is
Actually,
it
why said derivation वही होता है.
okay.
We will see that later on. Derivation वही है actually. We will integrate f into dr, so वही से we'll call it a potential energy. What Shaurya is saying, if you differentiate this minus du by dr, this actually turns out to be k q1 q2 by r square, which is nothing but force, isn't it? Work per energy में क्या ना, f is equal to minus du by dr. You can put on this potential का formula also.
Sir, here you took one potential energy as 0 now.
We are taking UB as zero reference. Clear? Let's see equation. So we have a square side A. We have an equilateral triangle side A. We have four charges here: Q, 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 centroid pe Q. Then what someone did, someone took these four charges and they kept them at the 4 points of a square. So you just twisted them and they're rearranged. So the four charges on a triangle are rearranged into a square. Find work done by external force. How much work you require in order to change from this to that? I hope you remember, work done by external forces, change in potential energy plus change in kinetic energy. यहाँ पे kinetic energy नहीं है. So you just need to find the potential energy of this system, potential energy of this system, and subtract them. Get it? I'll give you 2 minutes. Try. It's a good one.
So the reference point we can assume anything.
Doesn't matter. You're taking potential energy difference, so फर्क नहीं पड़ेगा.
Okay.
Try. Everyone should try. I'll give you a minute. Remember, what did I just say? If there are more than two charges, the potential energy of the system will be all possible pairs. If there are four charges, how many pairs are possible? PNC people. There are four, you have to choose two. How many pairs are there? 4C2, no? That is 6 pairs. Try. A minute. How many are there initially? See here we have 3 side pairs and 3 centroid pairs, na? So this is 3 into k q square by a. These are the sides, plus 3 into k q square by, what is this distance from the centroid? Centroid divides height in the ratio of 2:1. So this will be 2/3 of √3 a by 2, a by √3. kq square by a by √3. This is the initial energy, people. 3 side pairs and 3 centroid pairs. Here, how many are there? Here you have 4 side pairs and 2 diagonal pairs, na? So here the final energy is 4 into k q square by a, 4 side pairs, 2 k q square by √2a, 2 diagonal pairs. Oh yeah, so work done by external is u final minus u initial. Check. So you have to see all possible combinations that you can get. 6 pairs you will get. So for a triangle, 3 sides and 3 centroids. For a square, 4 sides and 2 diagonals. Get it? And what is the formula? K, Q, and Q2 by R. R is the distance between them. Check. Clear? Next one. Next one. This is another standard question. Came multiple times. You can expect again. Let's say we have a plus Q charge, mass m. We have a minus 2Q charge and mass is 2m. Initially, distance between them is d. Charges are free to move. So what will happen? They'll attract each other, right? Initially at rest and free to move. Find the speeds when the distance becomes half. And find the distance moved by the center of mass. The plus Q and minus Q will attract each other, so the distance will become half. So find the speed of the particles when the distance becomes half. Try. show you. Anyone got this? Yeah, Harsh, that is right. The displacement part is right. How do we do this? See, plus qm minus 2q 2m. This is your initial state, okay? And they're very far. Not so very far. This is distance d. Now, when they come closer, q and m, and this will be minus 2q to m, distance became d by 2. State 1, what is the kinetic energy? 0. What is the potential energy? Neglect gravity. So k, q minus 2q by d. What about the velocities? This will have velocity v1, this will have velocity v2. Conservation of linear momentum. Since f external is 0, actually acceleration of center of mass is 0. Velocity of center of mass here is 0. So center of mass will never move here actually. So here we see OM is 0. Therefore, center of mass never moves. Anyway, so from that we get P initial is equal to P final. Initially momentum is 0. Finally, it is mv1 minus 2mv2. v1 is 2v2. What is the kinetic energy here? Half mv1 square plus half 2mv2 square. What is the potential energy? Kq minus 2q. Distance has become d by 2. There. Since work done by external force is 0, energy is conserved. Initial energy is equal to final energy. This will become minus 2kq square by d. This will become minus 4kq square by d. Half mv1 square. If you can substitute v1 is equal to 2v2 there, that will be 3mv2 square. So we get v2 is equal to 2kq square by 3md per root. That's your v2, people. Check. Conservation of linear momentum, conservation of energy. So, like I said, right, instead of potential energy mgh, we are going to use kq and q2 by r. Check it out. Standard problem. Have a look at the steps. Do have a look at this. Clear with this?
Sir, could we conserve momentum with respect to center of?
Why you want to do that? You can conserve even center of mass is at rest. Doesn't matter. Next one. Same thing. We have a charge q, mass m. We have a charge q. Let's say mass m, and this mass is 2m. This is free to move. And you projected this charge with speed u from very far. You're getting? So we have two positive charges and one is projected towards the other positive charge from very far. Find the minimum distance between them. How do we do this? Can you tell me, like, see what is happening exactly? Both are positive, right? As it is coming closer, what is happening? This is getting repelled, this is getting repelled. So this guy is becoming faster and faster, this guy is becoming slower and slower. When do you think the minimum distance will occur?
V relative is 0.
V relative is 0, isn't it? Doesn't this look like two spring block and a spring problem? Only difference here, there is a spring, here is an electrostatic repulsion. So when you get minimum distance, what should be the velocity? Think about it. If the guy behind you is going faster than you, the distance will become smaller. If you go faster than the guy behind you, the distance will increase. At minimum distance, V relative is 0. That means both are going with a common velocity. We are done. So M, speed U, this is 2m at rest. Then finally, when they come closer, the speed will be V dash. This speed also will become V dash, and this distance is D. This is what you have to find. Conservation of linear momentum, mu is equal to mv plus 2mv. So V is u by 3. State 1, kinetic energy half mu square. Potential energy 0 because you're very far. State 2, kinetic energy half mv square plus half 2mv square. Potential energy kq q by d. Initial energy is equal to final energy. Half mu square is equal to 3 by 2 mv square kq square by d. Substitute u by 0, you'll get the answer from here. Check the steps. This was initial, and this was final. Easy? It's a good one. An easier question is this. Actually, JEE Mains they asked this simple question. This was fixed. Find the minimum distance. So this will come here and stop actually. That was an easier version. This is a much better than that. The other guy is also moving. Any doubts on this? Please have a look at this. All clear? Got this? Any doubts on this? Last one for the day. Easy one. So we have a charge Q here. We have a charge minus 2Q. We have a charge 3Q. We have a charge minus 4Q and so on. D comma 0, 2D comma 0, 3D comma 0, 4D comma 0, so on. Find the potential at the origin. Potential ka formula is what? KQ by R. It's a scalar quantity. There is no direction, anything. Just add it up. Let's finish off. Last one for the day. So next class when we meet, we are going to do things based on integration. So make sure to go through Centromaska once the elements how it is not difficult. For rod, we take small rods. For arcs, we take small arcs. For hemisphere, we take rings. And that's it. The next class will be full based on integration calculus based problems. And quite important. How to do this? Try. I'll give you a minute. show you. 0, 0 nahi hai. See now, the potential will be K Q by D. This is minus. Shit, it is 0 actually. Wait, I did a mistake. It is 0 actually. This is minus Q plus Q minus Q plus Q. Alternate charges. It is not 2Q, 3Q. Then it would have been 0. My mistake. This was KQ by 2D, KQ by 3D, KQ by 4D, and so on. If you take out KQ by D common, you end up with 1 minus half plus 1 by 3 minus 1 by 4 and so on. You know what is this? Ln 1 plus x ka series. X minus x square by 2, x cube by 3 minus x power 4 by 4 and so on. So if you just make ln 1 plus 1 ln 2, this will become 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, so on. So this thing is KQ by D ln 2. That's a ln ka series. Keep this in mind, quite a useful thing. We'll see this again in magnetism. So with this, we are done with field and potential of point charges. So next class we'll be doing based on continuous bodies. You can handle HCV up to first 30 questions exercise. This is something I kept on telling you, finish off your backlog, finish off your backlog. Last week I had only one class. You had enough time to finish off your backlog. So do start working on this, right? So any doubts, anything you can stay back and ask, or else you're free to leave. We'll catch up again on Friday as usual, 8:40. So do make sure to do all the 17 problems you have done. We have done some good ones.